Hello everyone, we are MARL Consultants and we're here to present to you today San Diego State North Life Sciences Building Civil Engineering Design. My name is Mohib Bishay and I am the project engineer as well as the hydraulic engineer for this project. For our project overview, the existing North Life Science Building is a 130,000 ground square foot, 4-story mid-rise, 1960s era science facility with a full basement level. The building contains a significant amount of SDSU's funded research as well as many science teaching labs. The building is programmatically outdated. The project shall replace the existing North Life Science Building and increase the development program from 130 ground square foot to 200,000 ground square foot to include the following. Increase research and support space from 39 square foot to 58 square foot, increase the teaching labs from 18,000 square foot to 27,000, increase office conference storage from 13,000 to 21,000, increase lecture and other instructional space from 3,600 to 5,500, increase floor to floor height from 13 feet to standard of the industry for higher educational life science buildings. And finally, increase the number of floors as appropriate to accommodate the increased square footage. And here is everyone in the MARL Consultants team.
Hello, my name is Mario Marcos, and I'm the construction manager for MARL Consultants. Thank you so much for giving me the opportunity to present to you the cost estimate of the new SDSU North Life Science Building in San Diego, California. I have provided a cost breakdown for every cost line of the project. This cost estimate is based on the assumption of multiple competitive bids and a stable bidding market. The project site work cost includes substructures, the building shell, interiors, services, equipment, special construction and demolition, and finally the building site work. The net direct site cost is $135,295,533. Adding the construction phasing allowance, which is an added 3%, the general conditions and bond, which is an added 15%, and finally the escalation to the midpoint of construction, which is an added 5%. The total site work cost for the new building comes to $164,008,627. I would like to also state that the unit cost includes all subcontractors' costs, including profit, labor, materials, and installation. Thank you so much.
This is Loha Zacarias, and I will be explaining the civil plans for this project in the next slides. The image on the right will determine the existing contour lines of the area and the elevations that the building will be after construction. The orange line on the image represents the cut and fill site view showed in the image on the left. For this project, the preparation of the terrain will be related mostly to cut due to the slope of the area. Going to the next slide, we can now determine how the site will look after construction. The orange area represents the new sidewalk for the building that is represented by the red area. We also plan the construction of a new plaza where in the present day has a small building in the corner of GMCS building block. We believe that this plaza will be necessary to the new demand of students and faculty in the area. Moving to the next slide.
Thank you, Lorhan. I am Marina Grace and I am the geotechnical engineer for the SDSU North Life Science Project. Some facts about our site are that it has an existing steep slope of about 50 to 60 feet in depth. I was provided some laboratory and field testing conducted by Group Delta consultants for our site. Based on 6 different boring location samples, I was able to estimate the surface profile for the proposed building site. Boring samples were 20 to 21 feet in depth and consisted of a surface layer, a fill layer, and eosine deposits. The top surface layer consisted of dense vegetation with large number of trees. The fill layer consisted of stiff sandy lime clay and was approximately 2.5 feet in depth below the surface. Finally, euxine deposits consisted of layers of clayey sandstone with gravel and silty sandstone with gravel and had a depth of about 18 feet. The diagram on the right shows the surface profile of the site with the different layer depth and some of the soil parameters. Some recommendations based on the geotechnical study are as follows. To prepare the site for construction, the removal of trees, vegetation, and other unsuitable material is necessary. Existing utilities on site need to be relocated or removed. To support excavation, it is recommended to use soil nail walls as it is less disruptive to traffic and causes less environmental impact compared to other construction methods. It also provides a less congested workplace, which is suitable for the project site. For the foundation, based on the soil bearing capacity calculated for the soil, the minimum footing width and depth should be 24 inches. Finally, for the pavement, the aggregate base needs to be compacted to a minimum of 95% of the maximum dry density.
This is Rita Isaac, and today I'll be presenting our team's structural specifications for this design. This new design will increase the size of the structure from previously being 130,000 gross square foot to now being 200,000 gross square foot to increase space for research and teaching labs, lecture rooms, conference, and office rooms. The floor-to-floor height is also being increased from 13 feet to now being 16 feet to meet standard height for higher education life science buildings. To accommodate such specifications, the total height of the building is to be 80 feet, which will include a basement and 4 floors above ground level. For the foundation, we will be using 12 by 15 concrete columns, which will have a load of 14 kilonewtons per floor. We are estimating 40 feet spacing between columns and 6-inch stirrup column to column. The beam load is to be 2.4 kilonewtons per floor, and the 6-inch brick walls that will be used will produce a load of 7.5 kilonewtons per floor. And now moving on to water study.
My name is Moab, and I will be talking to you about our water study. So our water study was conducted to determine whether or not the existing utilities that are at the location will meet the new capacity of the proposed building. So our water study included a couple findings as well as calculations to determine that capacity. Those findings included domestic water demands, meter sizing, and flow calculations as well as fire flow coverage. For our domestic water demand, we had to find a couple things. We had to find our average day water demand, our maximum day water demand, as well as peak hour demand. So we had to go off the assumption that we're going to have 1,000 students a day, and per the City of San Diego water manual, for school buildings, that is around 10 liters per student per day. So for our average water demand, that turned out to be 10,000 liters a day. Our maximum day water demand is 14,000 liters a day, and our peak hour demand is 23,000 liters per day. Thank you.
Thank you, Mohab. Hello, my name is Alhaiba Al-Alaw, and I am the hydrology stormwater engineer for the new North Life Science building. The intention is to design pipe systems to collect and convey rainwater from where it's falling to a safer place where it can be treated. The rational method conducted using City of San Diego Drainage Design Manual. Finding the time of concentration watershed area, I was able to determine the intensity, and the peak rate runoff was about 3.3 cubic foot per second. Here is the existing plan was obtained from San Diego State University. Proposed storm drain as shown on the plan with the blue line. Gravity pipe system to function properly, important requirements need to take into consideration, such as having enough slope for water to flow, the correct pipe sizing to prevent any flooding around the area. The pipe has to be far to be protected from the traffic on the surface, should be between 15 to 25 feet according to City of San Diego Drainage Manual. Here is some recommendations. Use RCP pipes instead of PVC, and installing trash collector within drainage inlet to prevent clogging. Thank you, and I hope you enjoyed our presentation.